Welcome back to my YouTube channel, Srinivasu SR Chaganti.
My dear students, this is the most important crucial time to revise the entire syllabus in physics, but sometimes it may be difficult to revise the syllabus at a time. Therefore, I am making certain attempts to make you understand and get good marks in the ensuing public examinations. Therefore, make use of this video and get good marks. Wish you good luck.
Consider a concave mirror of pole P, focus F and center of curvature C. Light ray passing parallel to the principal axis is incident at M and gets reflected through its focus F. The line joining M and C is normal to the mirror at M. From the diagram it is clear that angle MCP is equal to theta, MFP is equal to 2 theta. Here we can observe one more perpendicular drawn from M onto principal axis as MD. From triangle CMD, tan theta is equal to MD by CD. From triangle FMD, tan 2 theta is equal to MD by FD. Since theta is very small, tan theta is equal to theta. Tan 2 theta is equal to 2 theta. Once we replace the above equation MD by CD in the place of theta, we get MD by FD is equal to 2 into MD by CD. MD gets cancelled both sides. Therefore, CD is equal to 2 into FD. CD can be replaced by R and FD can be replaced by F. Is it not a wonderful experience? Observe rainbow in the sky. Yes, now let's see how rainbow is formed in the sky. Rainbow is a natural spectrum formed in the sky at the time of raining. The multicolored arc that appears in the sky opposite to sun on a rainy day is called rainbow. Rainbow is the combined effect of dispersion, refraction and total internal reflection sunlight. We all know that a white light is passed through a prism, it splits up into 7 colors called dispersion. The water drops in atmosphere act like small prisms and cause dispersion and total internal reflection of sunlight to form rainbow. By the way, what are the conditions to be satisfied for the formation of rainbow? 1. The sun and the space where they. Rainbow must be opposite to each other. In other words, the sun needs to be behind the viewer. 2. The sun needs to be low in the sky, at an angle of less than 42 degrees above the horizon. 3. The lower the sun in the sky, the more of an arc of a rainbow the viewer will see. How do you determine the resolving power of your eye? To find resolving power of eye, draw black bands of equal width, say 5 mm, with the separation of 0.5 mm between them. Gradually, increase the width of gap between black bands 0.52 to 1 mm, 1 mm to 1.5 mm after every 2 white bands. Paste that paper on a wall. When your distance from wall is very high, you will see only dark band, that is all dark bands merged into a single band. When you are approaching the wall, the bands seem to be separated into 2 groups with 1 white band between them. Now measure the distance d from the wall and also spacing between black bands, d. Therefore resolving power of eye is equal to d by d. In this way we can find resolving power of our eye. Formation of mirages, working of optical fibers and dazzling of diamonds are 3 more important applications which can exploit the best use of ray optics. How can we understand the above mentioned and observable phenomena? Let's go through the above applications. Let's have a quick look at 2 more important aspects called critical angle and total internal reflection to be clearly understood so far as ray optics is concerned. Critical angle. We know that bending of light rays when they travel from one medium to another medium is called refraction. Here, different light rays are focusing from denser medium with different angles. When a light ray is passing from denser medium to rare medium, the angle of incidence in denser medium, for which the angle of refraction becomes 90 degree in rarer medium, is called critical angle. The angle of incidence is greater than the critical angle, then the light ray gets reflected into the same medium instead of refraction, called total internal reflection.
This is an expression for the electric field intensity on the axial line of an electric dipole. Let us have a system of 2 equal and opposite charges separated by certain distance 2a. Here minus q and plus q are 2 equal and opposite charges. Here minus q is at a distance of r plus a and plus q is at a distance of r minus a from the point P respectively. For intensity of electric field at P, due to plus q and minus q are 1 by 4 pi epsilon naught into q by r minus a whole square and 1 by 4 pi epsilon naught into q by r plus a whole square respectively. Resultant intensity can be obtained by E is equal to 1 by 4 pi epsilon naught into q by r minus a whole square minus q by r plus a whole square, and simplifying it we will get q by 4 pi epsilon naught into 4 ra by r square minus a square whole square. The charge into distance 2a is dipole moment p. E is equal to 1 by 4 pi epsilon naught into 2p by r cube. Let us see how to find the electrical field intensity on the equator line of an electric dipole. Here is the system of two charges minus q and plus q which are separated by a small distance 2a. The magnitudes of electric field intensities at p due to plus q and minus q are 1 by 4 pi epsilon naught into q by r square plus a square respectively. It is obvious that y components of E1 E2 are equal and cancel each other. For the resultant electric field intensity due to x components is given by E is equal to E1 cos theta plus E2 cos theta. But from the diagram it is obvious that cos theta is equal to a by root of r square plus a square. On substituting E1, E2 and cos theta in the formula, E is equal to E1 cos theta plus E2 cos theta, we get 4 pi epsilon naught into q by r square plus a square into a by root r square plus a square. It can be neglected since r is very greater than a, therefore we get the required result. If two or more capacitors are connected in such a way that the potential difference between the plates of every one of them is same, then the capacitors are said to be connected in parallel. Let C1, C2, C3 be the capacitors connected in parallel, and Q1, Q2 and Q3 be the charges on these plates of capacitors C1, C2, C3 respectively. Therefore Q is equal to Q1 plus Q2 plus Q3. Here Q1 is equal to C1V, Q2 is equal to C2V and Q3 is equal to C3V. But Q is equal to Q1 plus Q2 plus Q3. Therefore CV is equal to C1V plus C2V plus C3V. Therefore C is equal to C1 plus C2 plus C3. The equivalent capacity of the parallel combination is equal to the sum of the capacities of the combination. For C is equal to C1 plus C2 plus C3. Capacitors are said to be connected in series if each capacitor stores same amount of charge but have different voltages. Let the voltages of these three capacitors V1, V2, V3 respectively. Series combination of capacitors, the total potential drop is equal to sum of the potential drops on the capacitors. For V is equal to V1 plus V2 plus V3. But we know that Q is equal to CV. Therefore V1 is equal to Q by C1, V2 is equal to Q by C2 and V3 is equal to Q by C3. And substituting these results in the equation V is equal to V1 plus V2 plus V3, V is equal to Q by C is equal to Q by C1 plus Q by C2 plus Q by C3. And taking V as the common factor and get them cancelled both sides, we get 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Now let us see how to find the capacitance of a parallel plate capacitor. To find the capacitance of a parallel plate capacitor, let us consider a parallel plate capacitor consisting of two plates 1 and 2 which are separated by a small distance d. We are considering the surface charge density of plate 1 and 2 sigma by 2 epsilon 0 and minus sigma by 2 epsilon 0 respectively. But electric field between these two plates E is equal to sigma by 2 epsilon 0 plus sigma by 2 epsilon 0 sigma by 2 epsilon 0. Surface charge density of plate 1, charge per unit area sigma is equal to Q by A. From equations 1 and 2 you can write E is equal to Q by epsilon 0 A. Field inside the capacitor E is equal to Q by epsilon 0 A. But we know that E is equal to V by D. From equations 3 and 4 we can write V by D is equal to Q by epsilon 0 A. V by D is equal to CV by epsilon 0 A. Therefore C is equal to epsilon 0 A by D. Phenomenon of apparent change in frequency received by the observer due to the relative motion between source and observer is called Doppler effect. O is the observer and source is in motion. Time taken by the first wave to reach the observer T1 is equal to L by V. Time taken by the second wave to reach the observer T2 is equal to T0 plus L plus Vs T0 by V. Therefore apparent time period T is equal to T2 minus T1. Therefore T is equal to T0 plus L plus Vs T0 by V minus L by V. L by V get cancelled. That is equal to T0 into 1 plus Vs by V. Therefore T is equal to T0 into, and taking LCM V plus Vs by V, and taking reciprocal we get 1 by T is equal to 1 by T0 into V by V plus Vs. We know that Reciprocal of time period is frequency n is equal to n0 into v by v plus vs. Source is approaching the observer, n is equal to n0 into v by v minus vs. The difference between apparent frequency and the actual frequency had by an observer is called Doppler shift. In this visual, the source is at rest S and observer is moving towards the source with velocity v0. L is the distance between the observer and S. V is the velocity of sound. Then the time taken by the first wave to reach the observer O1 is T1 is equal to L by V plus V0. Time taken by the second wave from the source S to reach the observer present position O2 is T2 is equal to T0 plus L minus V0 T0 by V plus V0. For apparent time period T is equal to T2 minus T1. Taking the difference between T2 and T1 and simplifying, we get T is equal to T0 into V plus V0 minus V0 by V plus V0. That is therefore T is equal to T0 into V by V plus VO. Reciprocal at n is equal to n0 into V plus V0 by V. N is equal to n0 into V minus V0 by V.
The question that she has asked me is, what is a wave and what are the different types of waves? As we have discussed already, light and sound travel in the form of waves. Material medium is required for the propagation of mechanical waves, as we have discussed. Generally, once energy is produced from any object, that energy creates a disturbance in a medium. That disturbance is nothing but a wave. A wave is a disturbance. A wave is a disturbance created in a medium which transports energy. Without transferring the matter as a whole. Without transferring the matter as a whole. This is the way in which you can define a wave. A wave is a disturbance created in a medium which transports energy without transferring the matter as a whole. Suppose I produce a sound by striking the table. It produces sound because vibrations are produced from the table as soon as I strike the table. The sound produced from this source moves in the form of a waves. That means this sound creates a disturbance in the medium. Thereby, it travels from the source to the human ears. But the sound itself does not move from here to there. What actually moves from here to there is energy only. What actually moves from here to there is energy only. So a wave is a disturbance created in a medium which transfers energy without transferring the matter as a whole. Means matter itself does not move from one point to another point. Only energy transport takes place. Suppose once you strike a bell, the bell begins to vibrate. The vibrations produce sound in the air. That means, in other words, it creates a disturbance in the medium. Thereby, it moves from one point to another point. That disturbance travels in the form of waves. I will tell you what are the different types of waves in the next session.
Potentiometer is a device used to measure EMF of a cell. Potentiometer generally consists of a wooden board on which a uniform Manganian wire of length 4 meters is fixed in parallel rows between two binding screws A and B by the side of a meter scale. A jockey is provided to make a contact at any point of the wire. The potential difference epsilon or E between any 2 points of the wire is directly proportional to the length of the wire between two ends. Epsilon is directly proportional to L. Epsilon is equal to phi into L. What is phi called here? Phi is the potential drop per unit length of the wire. So let us see what is the principle of a potentiometer. The potential difference E between any 2 points of the wire is directly proportional to the length of the wire. Let epsilon be the potential difference and L is the length of the wire. Epsilon is proportional to L. Epsilon is equal to phi into L. Now let us see what is meant by phi. Phi is the potential drop per unit length of the wire. Now we have to compare the potential differences of two cells whose potential differences are epsilon 1 and epsilon 2. To measure the potential difference or ratio of the potential difference of two cells or EMFs of two cells, here in the primary circuit a plug key K1 is closed. In the first position the points 1 and 3 are connected. Then epsilon 1 will be connected to the electromotive force of the first cell. Epsilon 1 will be connected to the galvanometer. At this point we have to measure the balancing length L1. According to the principle of the potentiometer, we have to find out the null deflection of the galvanometer. Electromotive force epsilon 1 is equal to phi into L1. In the second position 2 and 3 points are connected. Then again we have to find out the balancing length L2. Therefore, according to the principle of potentiometer, electromotive force epsilon 2 is equal to phi into L2. According to the first equation, epsilon 1 is equal to phi L1, epsilon 2 is equal to phi L2. Comparing 1 and 2 or dividing 1 and by the second equation 2, epsilon 1 by epsilon 2 is equal to L1 by L2. So this is the ratio of EMFs of two cells is equal to ratio of their balancing lengths L1 and L2. Epsilon 1 by epsilon 2 is equal to L1 by L2. By the way, now we are going to see how potentiometer is used to find the internal resistance of a battery. The construction principle of potentiometer that we have already discussed to compare the EMFs of two cells is the same thing as the determination of internal resistance of a battery. But the difference in the circuit can be noticed here. In the primary circuit, as usual, batteries, rheostat and K1 are connected in series. It makes the difference in the sense that in the secondary circuit, the internal resistance of a battery whose internal resistance will be measured and resistance box RB are to be connected in parallel. The other end of the resistance box is connected to the key K1, key K2, and these two are connected to the galvanometer followed by a jockey J. First step, the K1 is closed, keeping K2 open. The position of the balancing length L1 is noted. Therefore, according to the principle of potentiometer, EMF of the cell epsilon is equal to phi L1. In the second step, key K2 is closed. Then again, the jockey is adjusted to find the null deflection of the galvanometer. Then the balancing length L2 is noted. But the terminal voltage V is equal to phi L2. We have already seen the first equation epsilon is equal to phi L1 and V is equal to phi L2. Dividing 1 by 2, epsilon by V is equal to L1 by L2. The electromotive force epsilon is equal to I into capital R plus small r, where big R is the resistance of the circuit which is measured from resistance box, and small r is the internal resistance of a battery. According to Ohm's law, we know that V is equal to IR. Dividing these two equations 3 and 4, epsilon by V is equal to R plus R by R. Therefore, R plus R by R is equal to L1 by L2. That implies 1 plus R by R is equal to L1 by L2. When you bring this R by R to right side, it will turn out to be minus. Small r is equal to big R into L1 by L2 minus 1. Using this formula, we can find out the internal resistance of the battery. Therefore, the internal resistance of a battery small r is equal to big R into L1 by L2 minus 1, where small r is the internal resistance of a battery, big R is the resistance measured from resistance box R, L1 and L2 are their respective balancing lengths. Thanks for watching. Please do like, share and subscribe Srinivasa Sir Chaganti to get the continuous updates.
Dear students, welcome back to my YouTube channel, Srinivasu SR Chaganti. One of our aims is get 60 out of 60 in the ensuing intermediate public examination. But, sometimes you may not have much time to revise all the questions and answers within the stipulated time due to your hectic schedule. Keeping that point in view, I am making an attempt to put forward 10 minutes concepts in 10 minutes and get the benefits of getting more marks in less time. 1. What is dispersion? Which color gets more relatively dispersed? Answer. The phenomenon of splitting of light into its component colors is known as dispersion. Dispersion takes place due to change in refractive index of medium for different wavelengths. Bending a pilot component of white light is maximum due to its short wavelength. 2. What is hypermetropia? How can it be rectified? Answer. This is one type of eye defect. In this defect, eye lens focuses the incoming light at a point behind the retina. This is called farsightedness or hypermetropia. This defect can be rectified by using a convex lens. 3. Define power of a convex lens. What is its units? Answer. Power of a lens is defined as the tangent of the angle by which it converges or diverges a beam of light falling at unit distance from the optical center. Is also defined as the reciprocal of focal length expressed in meters. Its unit is diopters. 4. Define focal length and radius of curvature of a concave lens. Answer. The distance between center of lens and its principal focus is called focal length. The distance between center of lens to the center of curvature is called radius of curvature. 5. What is myopia? And how can it be rectified? Answer. This is one type of eye defect. In this defect, eye lens focuses the incoming light before the retina. This is called short-sightedness or myopia. It can be rectified by using a concave lens of suitable focal length. 6. What is the importance of Oersted's experiment? Answer. Oersted concluded that moving charge or currents produces a magnetic field in the surrounding space. 7. Distinguish between ammeter and voltmeter. Answer. Ammeter is used to measure electric current in a circuit. Galvanometer can be converted into ammeter by connecting a low resistance wire called shunt in parallel. In a circuit, it must connected in series. Voltmeter is used to measure potential difference. Galvanometer can be converted into voltmeter by connecting a resistance in series. In a circuit, it must be connected in parallel. 8. How can you convert the moving coil galvanometer into an ammeter? A moving coil galvanometer can be converted into voltmeter by connecting a high resistant wire in series to it. 9. What is the force on charged particle of charge q moving with velocity v in a uniform magnetic field of induction B? When does it become maximum? Answer. The force acting in a charged particle AF equals qvb sin theta. If theta is 90, then the force acting on the particle is maximum. 1. What do you understand by self-inductance? Answer. If EMF is induced in single isolated coil due to change of flux in that coil by means of changing current through that coil, then that phenomenon is called self-inductance. L euro equals LDI dt. The unit of self-inductance is Henry. 1. Magnetic lines form continuous closed loops. Why? Answer. In magnetism, magnetic monopoles do not exist. Possible ways to take a magnetic dipole. So the path of a free magnetic compass starts from north pole and ends with south pole forms a loop. Hence magnetic field lines are always closed loops. 12. What is paramagnetism? Answer. Paramagnetic substances are feebly attracted by magnets. In a magnetic field, the substances will move from weak field to strong field. Examples: aluminium, sodium, oxygen, calcium, manganese. 13. Classify the following materials with regard to magnetism. Bismuth, cobalt, oxygen, copper. Bismuth, diamagnetic substance. Cobalt, ferromagnetic substance. Oxygen, paramagnetic substance. Copper, diamagnetic substance. 13. Define magnetic declination. Answer. At a given place, the angle between two geographic north to the north shown by magnetic compass is called magnetic declination. 04. Simply declination. 14. What are the units of magnetic moment, magnetic induction, and magnetization? Answer. Magnetic moment ampere per square meter. Magnetic induction Tesla. Magnetization ampere per meter. 15. Define magnetic inclination or deep. Answer. The angle made by the total magnetic field be at a given place with the surface of Earth. In other words, the angle between horizontal to Earth's surface and net field of Earth at that point. 16. State Biot-Savart's law. Answer. The magnitude of magnetic field induction due to a small element of current conductor is directly proportional to the strength of the current element angle between position vector and the element, and inversely proportional to the square of the distance of the point from the element. 17. State ampere circuital. Answer. The line integral of the intensity of magnetic induction field around a closed curve is equal to mu times the net current bounded by the curve. 18. State Lenz's law. Answer. The polarity of induced EMF is such that it tends to produce a current. The change in magnetic flux. 19. What are eddy currents? Answer. When large pieces of conductors are subjected to changing magnetic fluxes, induced currents are produced in them. Such induced currents are called the currents or Folk-Arts currents. 20. What do you understand by self-inductance? Answer. When the current passing through a coil changes, an EMF is induced in the coil to oppose the change of current. This property of a coil is called self-inductance. 21. What type of transformer is used in a 6 volts bed lamp? Answer. Step-down transformer is used in 6-volt bed lamp. 22. What is the phenomenon involved in working of a transformer? Answer. Mutual induction is the phenomenon involved in working of a transformer. 23. What is transformer ratio? Answer. Ratio between number of turns in the secondary coil and the number of turns in the primary coil of a transformer is called transformer ratio. N's per Nepper equals V's, Vp. 24. Write the expression for the inductance of an inductor and a capacitor. Answer. Reactance of an inductor XL is equal to omega L. Dot. Reactance of a capacitor is equal to 1 by omega C. 24. What is the phase difference between ECMA and AC current in the following cases: pure resistor, pure inductor and pure capacitor? Answer. For pure resistor, the phase difference between AC voltage and AC current is 0. For pure inductor, the current lags behind the voltage by pi 2. For pure capacitor, the current leads ahead the voltage by pi by 2 pi 2. 25. What are cathode rays? Answer. The rays emitted from the discharge tube when the gas city subjected to low pressure 0.01 mm cathode rays. The cathode rays streams of electrons. 26. What is work function? Answer. The minimum energy required by an electron to escape from the surface of a metal is called work function of the metal. 27. What is photoelectric effect? When the surface of a metal is illuminated by radiation of suitable frequency, electrons are limited from the surface of the metal. This phenomenon is called photoelectric effect. The electrons emitted in photoelectric effect are called photoelectrons. 28. What are electromagnetic waves? Answer. An electromagnetic wave consists of electric and magnetic fields that are perpendicular to each other and perpendicular to the direction of wave propagation. This electromagnetic waves transfers waves. 29. What is the average length of X-rays? Answer. Wavelength of X-rays ranges from 10⁻³ nanometers to 10 nanometers. So the average wavelength of X-rays is 0.1 nanometer. 30. What is the principle of production of electromagnetic waves? Answer. An accelerating charged particle produces an electromagnetic wave. Visible light and ultraviolet rays are produced when electrons move from one energy level to lower energy level in atoms. 3.1 What are the applications of microwaves? Answer: it is because of short wavelength of microwaves. 1. Microwaves are used in radar systems for aircraft navigation. 2. Microwaves are used in microwave ovens to rise the temperature of food containing water. 3. They are used in speed guns to time first balls, automobiles, etc. 3.2 Microwaves are used in radars. Why? Answer: due to their short wavelengths, microwave easily penetrate through the Earth's atmosphere. Hence, they are used in radar for speech vehicle communication. 33 Give any two uses of infrared rays. Answer: infrared rad rays are used in Earth satellites, in remote control TV systems, for the treatment of skin diseases, for taking photographs where there is no visible light. 3.4 The charging current for a capacitor is 0.6 A. What is the displacement current across its plates? Answer: the displacement current is equal to charging current at every instant. So the displacement current is 0.6 amperes. 35 What is an N-type semiconductor? What are the majority and minority charge carriers in it? Answer: when silicon or germanium is doped with pentavalent impurity like our snake semiconductors formed. Pentavalent atoms add extra electrons and make it entire semiconductor. In N-type semiconductor, majority charge carriers are electrons and minority charge carriers holes. 3.6 What is the difference between intrinsic and extrinsic semiconductors? Answer: in intrinsic semiconductor like silicon, it is a pure semiconductor where number of electrons is equal to number of holes. Whereas a doped semiconductor with trivalent and pentavalent impurities called extrinsic semiconductor. In N-type semiconductor, majority charge carriers are electrons, minority charge carriers are holes. In P-type semiconductor, majority charge carriers are holes and minority charge carriers are electrons. 37 Water forward bias and in reverse bias conditions in junction diode. Answer: in forward bias conditions, VST terminal of the battery is connected to positive end of the diode and negative end of the battery is connected to negative end of the diode. In reverse bias, terminal of the battery is connected to positive terminal of the diode and positive terminal of the battery is connected to negative end of the diode.